Welcome to low-tech videos for Algebra 2 with geometry. I'm going to go quickly through this, but you're welcome to slow it down, rewatch it. Hopefully the notes will be actually enough for some of you, and so this one can be a bit low-tech because it's all review material. So equations of lines. Let's start with a nice horizontal line. Well, horizontal lines are such that the y value is always the same. So you model it with y equals 7. On a vertical line, the x values are always the same. And to describe a place where the x values are always the same, we're going to hit x equals -3. Why don't you hit pause and finish the next 4 questions, and we'll come back. So given 2 points, as soon as you notice that any 2 coordinates are the same, please don't bother finding slope. You know that this just is described by x is always -4, and a vertical line has slope that's undefined. This horizontal line has slope that's 0. So here our slope is undefined, and here it's 0. If you're given a super special point, like the y-intercept, please, let's use mx plus b. So we can see from these 2 points, we just need to find slope because we're already given the y-intercept. So we're going to find slope by saying change in y over change in x. Here we go up 9, so +9. Here we go up 6, +6. We're always going to reduce, so we're at 3/2 y equals 3/2 x plus 7. Once again, we're given that y-intercept. We know it's an oblique line, not a horizontal. So we're going to find slope, change in y over change in x. Here we go up 9, and here we go down 6. Oh, we're going to have a negative slope. Let's reduce. I like to put the negatives in my numerator. Usually students lose their negative signs less frequently if you attach that to the numerator. So we're at y equals -3/2 x minus 4. Hit pause, and you can do the next couple on your own. So be careful with your slope. Always reduce your numbers, and mx plus b. But your best friend this year is actually going to be point slope. So, not given no particular special points, point slope is definitely your best friend, and it's something you're going to be using more and more in your subsequent classes. So this describes any line that has a slope of m and goes through some point x naught, y naught. So let's try this. So here, not horizontal, not vertical, no y-intercept. Let's find our slope and pick a point. So our slope is going to be up 15 and up 3. So our line can be written one of 2 ways. Y equals -3, I'm going to use this point first, plus 5, x minus 2, or it can be written using this line, this point, y equals 12, plus 5, same slope, x minus 5. Let's try this one over here. Here our slope is going to be up 4 and up 12. And now we can choose this point first. We're going to say y equals the y value plus our slope, x minus -7. Oh, I'm going to call that x plus 7. Or we could use the other point. They're both equivalent. Y equals 3 plus 1/3 x minus 5. Try the next couple on your own. Except my computer keeps crashing. So here we're back again. We've got slope. We've got either of these equations will work fine. Slope, either of these equations. So this needs to be a formula that you have down cold and can use for given any 2 points at any time. Sometimes you're going to want to find the intercepts of your line. That means the place it hits the x-axis or the place it hits the y-axis. So if we look at this line, oh, look, I can't be fooled. The x is always the same. It's x equals 2. That means it's a vertical line with undefined slope. That means my x-intercept has to be 2. So 2, 0. But that line is parallel to the y-axis. That means there's no y-intercept. Let's try the next one. Oh, look, can't fool me. Y is always the same. That means it's a horizontal line. That means we know our y-intercept. It's got to be 0, 5, because the y is always 5. And we're parallel to the x-axis, so there's no x-intercept. Well, here's our best friend, mx plus b. Well, right off the bat, we like mx plus b because we know that our y-intercept happens when x is 0. We plug it in, negative 12. To find our x-intercept, the x-intercept happens when y is 0. So we're really doing a substitution. All we need to do is solve this. So we're at 12 equals 3 halves x. Multiply both sides by 2/3. Let's reduce. 3 goes in there 1, 3 goes in there 4 times. X equals 8. So that means 8, 0 is the x-intercept. Why don't you hit pause? Except I can't hit pause because, sorry, the sensitivity of my computer has changed since using this program last year. We'll all get the hang of it, I'm sure. So over here, make sure when you multiply by the reciprocal, take the negative sign with you so that you do it all in one step. And we get our y-intercept 0, 16 and our x-intercept x 0. So the next one, here we are in point slope form. So I'm going to put down a couple of things. One is I'm going to kind of run out of room here. Here we go. So one thing I want to notice right off the bat is looking at this form, I see it's point slope. That means I know I go through the point negative 7, 5. That's a very convenient thing to look at. So make sure you always notice that when you're in point slope form. So to find the intercepts, though, we need when x is 0 to find the y-intercept, and when y is 0 to find the x-intercept. The y-intercept, when you're in this form called explicit form, is always the easiest. So let's start there, because all it is evaluating arithmetic. So we're at y equals 5 minus 0 plus 7, oh, that's just 7, minus 7/4. The dreaded common denominator, our common denominator is going to be 4. That means there's 20/4 minus 7/4. We're left with 13/4. So when x is 0, my y is 13/4. When my y is 0, I just have a little bit of solving to do. But I definitely don't want to distribute this through, because then I'm left with more fractions that I really don't want to deal with, and I don't have to deal with. So first thing I'm going to do is subtract 5. Oh, because I could take this term, this is a monomial, it's only one term, and multiply it by negative 4. I'm going to do the same to the other side. That's how equalities work. This negative 4 and negative 1/4 equal 1. So I don't need that anymore because that's the multiplicative identity. Negative 4 times negative 5, positive 20, minus 7, x is 13. So you have been solving equations for a couple of years now. I'm giving you some advice on how you might want to consider solving equations to be more efficient. But again, there's lots of different strategies using algebra. So if you're comfortable and successful and proficient, meaning you get the right answer with the way that you do your solving, you are welcome to continue on that path. If you have troubles with proficiency and oftentimes get answers wrong, I'm trying to give you some advice that might work out better for you. I will run out of my 15 minutes of free video, so please pause here and do these on your own and check your answers when you come back on. So here's our x naught, y naught point. Again, that can be useful information. Here's how we found the y-intercept. Here's how we found the x-intercept. Again, I recognize point slope, so I'm going to grab that point because that might come in handy. You never know. Y-intercept, just evaluating arithmetic. X-intercept is a little bit of solving. Finding intersections. So for this one, we have a vertical line, x equals negative 4, that's hitting a line that has negative slope, and it goes through the point 5, 7. So 5, 7, just to get an idea, because then you can look at this and go, so that means my intersection is going to be over here someplace. It gives you a good visual so you can check yourself. Let's see what we've got. This is really a substitution problem. So if the x is always negative 4, really what we're doing is just solving not a system of equations once we put the substitution in, negative 4 minus 5. I'm going to pause the recording so when we plug in that x, we're just evaluating, we get our solution. Here we have a similar situation, and now we have a horizontal line, y equals 8. So we're up here at y equals 8. We have a positive slope line that goes through the point negative 6, negative 10. So negative 6, negative 10, way down here. So that gives you some sense of where that intersection might be. So it looks like it's going to be someplace in the first quadrant. We think, and we can just go from there. And again, it's a substitution. So we're really just substituting in y equals 8. We get 8 equals negative 10 plus 3/5, x plus 6. Finish it up on your own and come back and check your work. There we go. When we do the little bit of solving, we get 24/8. It looks to me that that's a reasonably sensible answer. But if we just have two oblique lines, then we're going to use substitution again, because that's the easiest, I think, for where we're at right now. And so we're going to substitute that y in for that y. So we're left with this, 7 plus 3/4 x minus 3 equals 3 minus 2/3 x plus 8. I'm going to run through this with you, and I'm going to write out my work, so I'm going to pause it one more time and come back and see what I did. So I subtracted 3, but now I don't like either of these fractions. So I'm going to do something called clear the fractions. And I see that if this has a denominator of 4 and this has a denominator of 3, if I multiply everything by 12, I can have an equation that doesn't have any fractions. So I just have to make sure that on this side I have a binomial. So I have to distribute it through to both of these terms. So when I finish all of my arithmetic, I get my x value, have to plug it